Welcome, everyone. Um, my name is Hillen. In this presentation, I'm going to talk about responsible responsive tables. I want to give an overview in this session about the problem that is caused for accessibility by responsive data tables. And I want to go over some of the available solutions that attempt to solve this problem. So the agenda for today is, first we're going to start with a recap, talk a little bit about data tables in general and responsive web design in general. Then we're going to talk about the accessibility challenge that responsive data tables pose. And then we're going to have a look at individual strategies. So first, a little bit about myself. My name is Hans Hillen. I am a principal accessibility engineer at TPGI. I've been there for 14 years now. And recently I've joined the SaaS content team there. So let's start with a little recap. Data tables are a very useful element in HTML. It lets you organize data with a logical relationship of 2 or more dimensions into a grid-like structure. And the benefit of that is that if you mark up your row and or column headers correctly, then somebody who cannot see that that content will still be able to look up information and compare information across rows and columns and kind of get the semantic structure and meaning for that tabular content. Responsive web design has been around for probably about 10 years now. It allows you to provide a flexible layout, a presentation that lets your content adapt to different viewport sizes so that you only need a single CSS-driven design that will fit and look great on any type of device or screen. As I said, this is CSS-driven, so this is done through media queries, where as you resize your browser window or you're viewing the content on a particular size screen, a particular set of CSS rules will be applied. And this is done through media queries. Now, the advantage for accessibility is that this is a great companion for your requirements for resizing and zooming content. As you increase the size of your content in a browser through browser zooming, the responsive breakpoints will kick in and the content will stay readable as if it was a giant phone screen, which really improves readability both on smaller and large screens for low vision users, and it reduces clutter. Now, the risks of responsive design for accessibility, and this is something that we see often when we do audits, is that it all depends on who designs and implements this responsive design. Responsive design by itself can be very accessible and actually improve accessibility. But if it's done wrong, then it's very easy to make it harmful for the accessible user experience. So, for example, a common mistake is that the smaller responsive layouts that are meant for mobile devices, for example, are purely based on the visual experience. So they look great, but the underlying semantics are not great. So somebody who cannot see that screen will not get the good content or structure. And the problem with the whole approach is that it is CSS driven, which means that you can't really change the semantics very easily because CSS generally doesn't affect semantics, only presentation. And another common mistake is that the smaller layouts, in order to say screen, will filter out content and will only show you some of the most important parts of it, but that's not a complete view of that content or features. So somebody who's might be interested in using that other content will not be able to, even if they are on a desktop screen, but they just have the page zoomed in very far, for example. So what's the challenge for accessibility of responsive data tables in particular? Here are some general issues. The first one is that data tables in responsive web design just don't go along at all. They don't fit. Data tables are two-dimensional by their very nature, and they require width as well as height. And responsive web design expects the content to be able to reflow to a somewhat one-dimensional structure. And it's not literally one-dimensional, but it means that you can view that content as a big, long, narrow column where everything is vertical and there's very little width required. So those two things just don't get along. Data tables, if you were to view them on a narrow screen, would probably mean that you require some kind of horizontal scrolling, which is something that we generally don't want. And the other problem is that there just isn't a straightforward reflow strategy that everybody knows how to use or can use. There's no simple attribute that you can add to your table to make it automatically responsive in an accessible way. So, somebody needs to actually be aware of the problem and be aware of the available solutions and then pick the best solutions from those. So when I was looking into the available strategies, I came up with a list of accessibility requirements. So these are the things that I want a responsive table to do in order to be accessible. And when we're going to look at the strategies later, I'm going to see for each strategy how well they did on each of these requirements. So the first requirement is semantics, which means that we want our content to always expose a useful structure and semantic information in addition to just the visual look and feel. And this has to happen on all responsive layouts, whether it's on a desktop screen or phone screen. The second requirement is mapping, which means that whatever is being shown visually on the screen at the moment needs to expose matching semantics. So again, if a blind person were to collaborate with a sighted person, you don't want that sighted person to say like, oh, you just have to go to the second item in the accordion, in the expandable accordion, to find what you need, when that blind person is actually perceiving there to be a data table there, because that's a complete mismatch of what's there visually, and that hampers collaboration between people. The third requirement, vertical. As I said, we prefer there not to be a need for horizontal scrolling. It should just be a one-dimensional scrolling experience, which means up and down. If you then also have to scroll sideways, it's an extremely poor user experience. Complete is another requirement, which means that all content must be available across all breakpoints. We don't want content to be removed just because you're viewing it on a smaller responsive breakpoints, because it's up to the user to decide what content is important, and we shouldn't be deciding that for the user. Then there's lookup, which means that we want to keep the benefits from a data table, which allows you to go up and down a row or sideways up and down a column or sideways along a row to compare and look up data on those dimensions. We want that to be able to be done on all responsive layouts. And the last one is complexity. It's all fine and good to have simple data tables be made responsive, but we want it to be possible to also make more complex tables responsive. So these are tables that have, for example, nested headers, or tables that can be sorted by column or filtered or have paging controls. Then there is another set of requirements that is less important but still nice to have, and I'll mention those as well. The first one is CSS. As we said, responsive web design is a CSS-driven solution. So in order to keep the data tables approach, purely responsive, it should be CSS driven as well, and it shouldn't involve any scripting. The second requirement is unique. We want there to be one version of content on a page. We don't want there to be redundant duplicates. First of all, it improves or it burdens the bandwidth and the file sizes, but it also would cause a very confusing user experience if somebody were to turn CSS off if they saw the same content in different formats. Level of effort should be low. It should be very easy to implement this solution for a developer, which basically means that it should be possible to automate. The fourth one is scalable. Solutions should work for small tables as well as large tables. Then there's intuitive, which means that it should be very easy for a new user to understand the structure and semantics that are being exposed for the table on all responsive layouts, even if it's their first time, and ideally not have too much of a learning curve. And the last one is consistent. We want content to be recognizable across all breakpoints, so that if somebody were to view a web page on a laptop screen and then view the same page on a phone screen or tablet screen later, that they can still recognize the content they were looking at, and that it doesn't look like something completely different. So those are the two sets of requirements, the accessibility requirements and the nice to have requirements. So now we're going to have a look at some of the strategies. There have been many solutions offered, as I mentioned already, over the last 10 years. But they basically all fall in the following categories: column squashing, horizontal scrolling, column filtering, and reflowing structure. And I'll explain what each of those mean as we move on. Now, based on this research, what I found is that the perfect strategy to use for accessible responsive data tables does not exist. There is no solution that I found, at least, that matches all of those requirements perfectly. And each approach has its strengths and its weaknesses. And it really depends on the type of data that you have, which solution you should pick. So even though there is no perfect strategy, that doesn't mean that there aren't any good strategies that will improve the accessibility of your responsive table. So that's the good news. Now, of course, there are very many different types of tables out there, and we only have a short time available for this session. So here on the screen, for example, there is a table that is very common these days. This table represents different mobile phone plans from a phone provider, where each column is a different plan, and each row has different properties about those plans, like how much data you get, what the price is, how many minutes you get. So while this is a common table, we're not going to be looking at these kind of tables in this session, even though those tables usually are responsive, but they're not very accessible from what I've seen. So instead, we're just going to keep it simple, because that's complicated enough about this topic, and have a basic, straightforward data table. This is the sample table that we'll be using when we're going to compare all the different solutions. It's a table that has volunteers as a caption. The rows are different volunteers. So we have their names, first and last name, and then things like age and email, phone, occupation along the columns. So it's a very straightforward data table, but it has 12 columns and quite a few rows. So it's quite a big, bulky table, even though it's simple in design. So the first strategy that we're going to look at is column squashing. You might as well describe this solution as doing nothing. It's not necessarily a responsible thing to squash things or make them more narrow. That's been done for years, way before responsive design came along. So this is a strategy where you just make the columns smaller on smaller screen, the screen sizes, and you basically squash the width of each column. The advantage is that the table is left as it is, so you have all the structural and semantic benefits that tables provide. But the problem is that the solution does not scale well at all. So remember that we had 12 columns in that sample table, and here you see that we can only fit 3 in. So when we're going to have a look at this in practice, here's that same column with 3, or that same table with 3 columns. And I have a little button here that lets me simulate the screen becoming more narrow. And you can see the columns being squashed and becoming more narrow as well. And now you have a very neat view of those columns. So that's nice when you only have 3 columns, but if we go back to the table that we actually had with 12 columns, if I do the same thing, you can see that it actually doesn't fit the table at all, and now most of my content is cut off. So that's not a good approach for large tables with many columns, or tables with columns that have a lot of content in a column, like entire paragraphs of text, for example. But it could be a suitable solution if you only have 2 or 3 columns. So if we're going to look at the requirements real quick. The semantics are okay, the mapping is okay, but there's a lot of scores here that say yes, but actually have an asterisk behind it. Like yes, you don't need horizontal scrolling as long as you only have 2 or 3 columns with not a lot of content in it. And yes, you can see all the content, but only if it's a small table. And the biggest issue is simply that this approach is not scalable at all. So most realistically, this table is not going to do it for you, at least not on the smaller screens, maybe on the medium sizes. Now the next solution that we're going to look at is horizontal scrolling. So again, the table is left intact, but we wrap it in a scrollable container that can scroll sideways. It's a very simple approach that's easy to implement and supports table of any size. But we are breaking our own requirement there, our own rule, that we don't want to be scrolling sideways. So this solution isn't really responsive, even though it's quite common, and it is an accessible solution in some ways. It's not the most user-friendly. So if you look at Bootstrap, for example, they have a responsive table class that basically does exactly this. So I have a demo here as well that I made myself. Again, if I'm going to make this screen smaller, or pretend to be smaller, you can see that we now have a scroll bar at the bottom, and we can scroll sideways so that we can still get to all the content even if the screen is too narrow. Now, what's very important is that the moment that you start adding scrollable containers to anything, it needs to be possible to perform those scrolling actions with the keyboard as well, and not just with a mouse. So in that case, you need to make sure that the container that's scrollable is also focusable. And in order to be really wicked compliant, it should only be focusable while it's scrollable and not on the larger sizes. And then you can move focus to it, and you can use the arrow keys to change the scrolling position. Now, of course, the moment that you make it focusable, that means that it needs to have meaningful semantics. So we need to give it a proper role and accessible name. And since this is a container, you could use a role of region or a role of group. And then you could use an area labeled by attributes to target the caption element. So since you can only see part of the table at any time, it's not easy to look up values along rows. And combined with the scrolling solution, it's not, or the scrolling problem, it's not the best solution. So here are the requirements again. It doesn't match the, or doesn't pass the vertical requirement because we do have to scroll horizontally. We can't do lookup. So, while it's a good and simple solution, it has some serious flaws. Now you might wonder, what does WCAG have to say about this? Because most of you will probably know that in WCAG 2.1, there was a new success criterion called reflow, which says that you should basically be able to present any content without requiring scrolling in 2 dimensions. But most of you will then also know that there's actually another exception there for that particular success criterion that says that this does not apply for content that requires 2-dimensional layout for usage or meaning. So you might think, well, what does require mean in this case? Because as we're going to see, we can, reflow any kind of content that's 2-dimensional to, to be 1-dimensional if we really want to. But there's actually another note making it more clear that says, examples of content which require 2-dimensional layout are data tables. So if you see somebody using that scrollable table technique, and you're an auditor or a QA tester, for example, you cannot use success criterion 1.4.10 to flag that as a violation because it's exempt for data tables. Doesn't mean it's a good practice, but it's not covered by WCAG in this case. Now the next approach that we're going to look at is column filtering. With this approach, you basically hide the lower priority columns as the screen width narrows. It can be done for the user by the content provider who may identify what columns are the most important ones. Or it can be done by the user, but ideally it would be done by both. So I added here that it's both a pro and a con. The fact that the user can choose, because obviously we want things to be customizable. We want the user to have the control over it, but then again, the user isn't always right and may not know what's best for them or may not understand that they can actually modify the view. And since we are filtering things out now, we don't really get a complete view of the data on smaller screens. So here's another demo. There's a table which has a drop-down button above it that lists all the columns as checkable items. And you can set it up so that based on which breakpoints are hit, it will automatically hide certain columns. So if I resize this window, it automatically narrows the amount of columns being shown. But the user, like I said, can also do this themselves and just pick the columns that they find useful and hide all the other ones. So if you just want to look at education and occupation in this table, for example, you would hide everything else. And then when we make it smaller, it's still too wide, so we can hide one more. So we get rid of occupation. Now we have a table that fits. And this particular demo is using a plugin called TableSol, which is developed by the Hillen group, which we'll be looking at more later, but it's a very good solution for various responsive table approaches. And the way they've set it up is that if the user chooses more columns than fit on the screen, it will just become a scrollable table like we've seen before. So it's really up to the user how much of the content they want to be able to see and whether they want to be scrolling for that content or not. So now we're on a larger screen again, we would have to unhide some of these. So because it's you only see part of the screen, it's not easy to do a lookup across a row. It's not a complete view of the data, and whether or not you require horizontal scrolling really depends on the user in this case. Also, this solution is hard to do with CSS only if you want the user to be able to have a choice, so you're going to be dependent on some scripting there. Now, another version of the filtering columns approach is to use overflow rows. With this approach, you heavily rely on scripting, and you basically keep an eye on how many columns actually fit in the screen at any time. And anything that doesn't fit on that screen is put in an overflow row that can be expanded or collapsed. So let's see that in action, because it probably explains it a lot better. So here's a example that uses the datatables.net plugin, which is a very useful plugin for quickly making very cool data tables with lots of extra features like paging controls and searchable columns, filterable columns. So if we were to look at this table on a responsive layout, and I'm just going to use my browser's DevTools for that. You can see that the table automatically limits itself to the available amount of columns in the available space. And there's now a little icon on the left that lets you expand all the columns that were cut off. And those columns, instead of being columns, are now shown as a basic list. So if we're going to look at the code here, you can see that this content is now added to an extra row in a column that spans the entire row, in a cell that spans the entire row, and it's added as an unordered list. So it has semantic structure that matches the visual appearance. Now, you can't do proper lookup with this anymore. Like, you can't compare, the different ages very easily, for example, or the different education levels, because you have to expand all of them and they're not lined up anymore in a nice, neat column. So that's the downside of this approach. But another downside is, and it's something that's particular with this particular plugin from datatables.net, is that while it's a very cool solution that really uses the available space very well, and visually it looks great, but if you look at the code, there's definitely some accessibility issues with it. So first of all, every first cell in each row is in the tab order, because you need to be able to tab to it and expand it with the keyboard. So they did think about that, but they didn't think about that the cells don't need to be in the tab order when you're viewing the table on a regular desktop layout. So if we're going to tab to it now, it's still going to highlight every individual cell, and that's just cluttering up the tab order. In addition, there's nothing semantically provided there to make it clear to somebody who can see that screen that this table can be expanded and collapsed, and whether it's currently expanded or collapsed, what its expanded state is. And it also doesn't indicate that this additional row is actually nested into the other row, conceptually speaking. So there's definitely some things that could be improved with this solution, but that doesn't mean it's not a valid solution. These are all things that can be solved. If you want to try this yourself, you can just take those issues that I just mentioned into account and make it a really accessible solution. Now, is it the most intuitive solution? That's not really clear for all users, I think. I think if somebody were to encounter this at the first time, it might not necessarily be the easiest to understand what's going on, especially if you can't see the screen. But after a little learning curve, I think it's probably a very good solution for things like corporate software or corporate sites where you have intranets, web applications that users keep coming back to, and then once they've been through that learning curve, they have a better understanding of how it works, and they get to see all the content on any type of screen. And that's the nice thing about this, that nothing gets cut off, nothing gets hidden, and there's no need for horizontal scrolling. So the lookup requirement fails. It's not a CSS only solution by a long shot. It's not unique because we are duplicating content, and it's not necessarily intuitive or consistent. But it is a useful solution to consider for sure. The last category that we're going to look at is structure reflowing. So when you use structure reflowing, you're basically overriding your table's display styles. And you do this for all the table related elements, such as the table itself and the table rows and the table cells and the table headers. And if you change that display style to be block or inline block, for example, you're removing the way that a browser normally renders a table, and that allows you to reflow that content completely and have it shown as a list, for example, or as an accordion. Now, the problem is that when you do that, you also remove any semantics that the browser was currently exposing for that table. So that structure is now gone, and you just have a bunch of values that are structureless and semanticless. So somehow new semantics will have to be provided, which again, as I said, is very useful to do without scripting. Now, the other thing to keep in mind is that with this approach, the column headers that are normally at the top of the table will have to be repeated for each value. You can see it here on the right, and we'll look at it in an example later as well. Last name, first name, age, email, all those things will have to be repeated over and over again for each row. So that's a lot of additional clutter and extra content that you need to inject into the code, into the DOM. And also, it's not easy to look up content, as we saw before, because it's not lined up anymore. So here's a little example that is also from the Table Sol plugin by Filament Group. If we look at the mobile version of this view again, you'll see that rather than table rows, it's now shown as kind of a listed group. But when you look at the underlying code, the semantics haven't really been resolved. So if you look at this table cell, for example, you can see here that the display style has been overridden and changed to block. And that means that that cell no longer has a meaningful role or structure. And basically, a screen reader wouldn't really have much use for this kind of structure. It would just be reading all the content in order. So it's not like content would be missed, but it's not a nicely structured set of content anymore. So while that can definitely be resolved in this particular example, while it looks good, the semantics behind it could be improved. So in this case, for this particular example, the semantics requirement is not matched, which means that the mapping requirement isn't matched either. Content is no longer lined up, so it's hard to look up or compare information. And this approach probably wouldn't work for more complex tables. It's not a CSS only solution, duplicates a lot of content, and it's not necessarily consistent across different breakpoints. Now, another approach to this is rather than just reflowing the content, is to use swapping, which means that you basically just replace the table with an equivalent version of that content that matches the other responsive layout better. In this case, you would just hide the table on smaller screens, and then you would unhide or inject an equivalent version of that table on those smaller screens. So you're not modifying the original table at all. You're just hiding it and showing something else instead. And this allows you to have really complete control over both the visual appearance and the semantics being exposed, because you're not limited to the CSS. You can just put all the semantics you need into the HTML directly. And the solution can be a CSS-only approach. You can just have things hide and unhide at various breakpoints to show the ideal version of that content. But there is a lot of redundancy as a result for that, because you would need multiple versions of a table. And with this in mind, it makes it a really good choice for a React component, for example. Like, let's say if you want to have a responsive data table that's accessible, you could just make it into a single React component that automatically replaces the content the way React does that as the breakpoints are triggered. So here's a example that uses a demo created by Hayden Pickering. And it's a pretty cool React component that does sorting as well. If you look at this table on the mobile view, it looks very similar to the previous demo, where everything is kind of grouped into a 2-column list. But if you look at the underlying code, you'll see that that table is now no longer the actual content. So the table's here, but the container that it's in is hidden with display none. So that's actually no longer in play at this point. The content that is actually being exposed to the user at this point is something completely different. So we now have an H3 element for every row header, followed by a description list or definition list if you've been around for a bit longer, where each column header and value pair is implemented as a DT and a DD element. So this is a completely accessible view of this type of content. Headings and definition, description lists are completely valid in this case, and it completely matches the visual appearance as well. And you don't have to worry about the table anymore. You don't have to worry about changing display styles or what that would do to semantics or how you would add semantics to it. So I really like this approach. Obviously, you don't need horizontal scrolling in this case. And the only downside is that you can't line up content anymore. And you know, if you had very complex content that has a lot of paragraphs in it, for example, it might not necessarily fit. So it really depends on your content. But it's a good solution nonetheless. So in this case, it's not purely CSS driven, this particular example from Hayden Pickering, but like I said, if you're using the swapping approach, it could be CSS driven. And it's not unique because we have redundant versions or redundant copies basically of the same content on the same page. I wouldn't say it's a low level of effort to implement, because you really need to know what you're doing, and even setting up the React component can be kind of complicated. And there's no lookup, and this probably wouldn't work for very complex tables. And it's not consistent because the table is shown and the content is shown in a very different way across breakpoints. So those are the most common approaches that I've seen, and as I've said, there are many more articles and functioning examples out there that you should definitely look at. But they all kind of fall into these kind of approaches, if they're accessible at least. So what are the conclusions that we can take from this? First of all, what the perfect solution is for you will really depend on what kind of content you have. How complex is your table? How much content is in there? How wide is it? How much content can there be in a specific column at a time? So, think about what kind of content you're working with and what solution will work best for that content. Definitely make sure that whatever solution you implement in the end, that it's automated, because you don't want to be doing any of this by hand. It's just a very error-prone process and very time-consuming. So make sure that you have it all scripted and set up automatically, so that it's done for you. And if needed, it needs to be scalable as well, if you have larger tables. Now, rather than locking a user into a solution, consider allowing the user to actually choose what their preferred approach is. So for example, that table saw plugin that the filament group created actually also allows a drop-down menu to choose between responsive table types or modes. And you can switch, for example, between a scrollable table or a stack table, where the whole thing reflows, or they have some other options as well. And if you let the user choose, then at least you're not forcing them to do something that they might find unpleasant to use. And with that in mind, always allow the user to just use the original table if that's what they want, because in the end, tables are good for accessibility. And if you provide a link or a button next to the table that says like show original table or revert to original table, then that's good, and you leave that option open for the user. And if you do use reflowing, always make sure that you expose correct semantics and structure. Don't just go by the visual alone, because that's not sufficient for accessibility. So here are the resources that I mentioned. There's a lot more content in there, much more in-depth, and many code pen examples that you can try out, and links to other articles. So definitely have a look. Particularly interesting, I think, is the Chris Collier one, which basically was kind of the first to work with this, I think. My colleague, Adrian Roselli, has a really good article about how to override data table display styles and all the things that you need to think about when making the table responsive. And the inclusive component by Hayden Pickering that I've showed before, which is the React component. Those are all very good, and the other ones are good as well. And here are the demos that I've used that you can link to. As I said, the table saw component by the filament group, the datatables.net component with the responsive plugin. There's some CSS only solutions. There's Hayden's React component, and there's the components that I've used in this presentation, which you may want to have a look in as well, even though they're very basic. So that was the end of this presentation. Thank you for attending, and I hope to see you again soon. Take care.